Good morning, good afternoon, good evening, everyone. Thank you very much for joining us today on another Wallaroo webinar. Uh, Lots of W's in there. Today, we've got an exciting session, another exciting session. Same as the other ones. We're going to go deep into a specific topic. And the goal of this is to help you as you go through the journey of adopting AI and putting it into production and really achieving those results and ROI that you want to get from the effort that goes into these projects. Specifically today, we're going to cover continuously delivering AI at the edge, and we'll focus specifically on the use cases of computer vision. Those are the most common use cases that we see for edge AI today. And there are many obstacles that companies are facing, not just in Edge, but across AI in general, in getting these projects from ideation and development into production. It still continues, unfortunately, to be the biggest hurdle that enterprises make to get those projects into a production environment and start making them work for them, to make them, that process easy, to make that process flexible and also efficient for them. So we have a great session here today that we'll go through and some really expert panelists in the industry, and we can draw upon their knowledge and expertise and skills to help us on this journey and come away with that knowledge and that fortitude to move our own projects forward in this space. I want to we'll set a couple of things here to go ahead. What we'll do is we usually have a sort of little presentation from each one presenter, but what we'll actually do this time, we're taking a little bit of different approach. We're going to have Q&A from each of our panelists. We've got three core pillar topics that we want to go through. But you, the audience, we really appreciate that you've taken the time out of your day to be here. We know there's a lot of things competing for your time, and we do appreciate it. And so we want to keep this interactive. We have the opportunity where if you have questions, please post them in the chat, and we'll make sure that we get to them in the session itself. And we also have Q&A at the end if you want to save your question at the end. So please, let's keep this interactive, because we're here for you at the end of the day. We want to make sure that you get the most from this time. Now, to kick things off, I talked about the great speaker panel that we have, and so I'd like to introduce that panel. If each of them could come on camera as I mention your name and intro. First of all, Manny, please, could you introduce yourself?
Hey everyone, Manny Calero. I'm a consulting solutions architect at Zededa. Good morning, good afternoon.
Awesome. Thanks, Manny. Great to have you here. Next up, I'd like to invite Yunus. Leonidas, please introduce yourself.
Thank you, Martin. Yunus, I'm our VP of Product at Wallaroo. Looking forward to sharing some insights and learning from you all.
Awesome. Great to have you back, Yunus. And finally, but definitely not least, please, Deshaun Carter.
Hello, I'm Deshaun Carter. I'm a Spring Developer Advocate. I love my job and I'm jazzed to be here.
Awesome. We love that. We love that energy, Deshaun. It's great to have you here, and looking forward to getting into the insights from all three of you to help our audience here on their journey through Edge AI and computer vision. Now, before we get into our first pillar topic, what we're going to do is we'll just take a quick poll here, and from the poll, what we really want to sort of find out is, where are you right now in that journey? And so, please, if you could put up the poll questions, and we'll give the audience a chance to respond to that. So we want to know which industry you're working in. Edge itself, spans a number of industries. We see it in retail with self-checkout, tracking industry. Manufacturing have been doing IoT since before it was called IoT. And with the advent of the Edge, they are trailblazers in this space. We also see it through government, the emergence of smart cities, and also in health and life sciences. We saw that very much with COVID and the generation of the virus and analyzing the virus itself. So Great to see this, and then the other ones are automotive, telecommunications, etc., that lend itself to this space. So it looks like everyone is in that other category. So great to see that, and we have some manufacturing folks as well. So awesome to see that. So great, thank you for responding, and let's kick on to our first topic here from our panel. And essentially what we want to sort of, dive into here is scale. When we talk about edge, we're not just talking about one deployment or one device. We're talking about many devices, many deployments over, large regions or geographies and so on. I did work in one project where it was a, grocery store chain, and they had 240 stores across the country monitoring the fresh produce. So you have different climates, temperatures, etc., that you have to cater for, the ripeness and the spoilage, tracking of that produce. And so the question for the panel is, while Edge opens up these opportunities to extend and scale those AI workloads, like how do you help sort of improve and accelerate that decision making, and really making that decision making an advantage for the enterprise? And just quickly before we get into that, I'll give you an example of what I mean by this. When I talk about that project, we were sending the computer vision data across a mobile network to a centralized location to be processed. While the project itself was successful, the cost of sending those images across that network was cost prohibitive. And so how do we help companies do that data processing and that decision making at the edge? And so if I'd like to, Deshaun, I see you nodding there. Please, we'll kick off with you.
Yeah, like just the point that you made, we can capture these images, and there's lots of cloud services that you can go use to analyze the images, but doing that at scale is cost prohibitive, right? And we've seen that. I could reference dozens of these examples of, hey, I'm going to take an image from somewhere, and on the edge is even more difficult. You mentioned a mobile network. Taking an image from somewhere, transferring it someplace else to have some analysis done, and then you have to take the action. The exciting part about what we're doing here is we're talking about you can actually do the analysis next to the use case, right, where you need it, and you can stay there, save money, and have better results, closer results. So yeah, this is all a win.
Definitely. Manny, I mean, you've also seen the growth and evolution of these edge devices from, larger, just machines or devices that are collecting information to the processing power. What are you seeing in this space for the ability to scale and manage that data at the edge?
So from my perspective, from our inception, right? So our founding was to target customers like oil and gas, distributed, disconnected, insecure locations. And then as we evolved and our platform grew, we get a lot more takers in the retail space, for example, now in retail edge, as you mentioned, right? Our networks, not just mobile, you mentioned the mobile network, but our networks, period, were designed asymmetrically, right? They're not designed for upload. So you always have that challenge of having to transfer, high resolution, video or photos, which cause a high cost of transferring, and then of course introduces latency and all kinds of different elements that can affect the way that real-time AI requires to perform well. So yeah, I always go back to the asymmetrical design of our networks and how that affects the criticality of AI and having to transfer long periods and long distances to the cloud like we normally do. Um, and so you mentioned scalability. So from a platform perspective, the ability to scale isn't just the ability to manage a fleet of different endpoints, but is the platform designed to manage fleet? Can you deploy in mass? Can you create policies that apply to multiple endpoints at the same time? So those are the kind of things that we're seeing, and and how it gets applied into the industry.
Fantastic. Eunice, I think we've also had some experience with customers looking to, expand into, these edge devices, and then I'll hand it over to you if you want to expand on this topic.
Yeah, absolutely. We have a little bit of experience, just a little bit. And of course, we have surveyed the market. If you don't mind, actually, control room, going back into the first slide, and the opportunity that we saw before we actually started investing in everything related to scaling out edge AI deployments. One key thing I wanted to highlight from this market graph is that you can see that computer vision is something that is becoming valuable. Now, when you think of computer vision analytics as a way to actually now harness that modality, that data modality, and be able to generate insights from it, it's something that it is becoming valuable. It's actually past that trough of disillusionment. But one thing that we want to highlight here is that time to insight is great. Time to value is basically where it's at when it comes to fully realizing the potential of AI. So when you look at particularly edge and the stat of data being fully distributed, especially with the prediction that 50% of data is going to be outside of the data center, you will see that basically edge AI is the main enabler to accelerate and automate decisions off of that data. That's really what it means to achieve time to value. It will reduce costs. It will also accelerate decisions. It will give enterprises a competitive edge, no pun intended here, over there in their respective markets. And actually, that will basically, if you go to the next slide, please, one of the things that we're anchoring ourselves on is basically turning that 90% failure rate or generating ROI from AI into actually success. And one of the key items that we have anchored on the Wallaroo side is turning that inference into value. And one of the key things that we will see is, and the team discussed here, is complexity and cost in generating those insights or generating that value, automating those decisions, but also the variety of workloads that we're going to be seeing. Computer vision is the main driver at the edge, but we're going to see other modalities coming over, especially with data becoming multimodal and being fully distributed across all the systems and environments that enterprises tend to own these days. That's it for me.
Awesome. Great. Uh, and it is very important, and as we talk about, where you're not just having one deployment, right? You're having many, especially from the poll study there. We saw respondents in the manufacturing space, and you have all these machinery. They're all measuring different things, from wearing out of bearings, or the quality of the product coming out. And so all that information, having that processed at the edge is super important. And again, I'll bring this back to one other project I worked on at my automotive manufacturer, where we went in and we said, okay, when the metal gets pressed and cut, they needed to look at the layer of oil on that, making sure that there was no degradation in the quality of that panel that was being created. And we said, okay, and
That's just me. I think I'm not hearing Martin.
Yeah,
I think we may be experiencing some difficulties.
Okay.
Let's give Martin
you
a
know,
chance to come back.
Oh no, we've lost him.
sorry,
But
am I
where he
back?
was going, right? This analysis at the edge, where he was going, that is another thing where sometimes it's not just about being able to take actions at the edge. Sometimes it's just purely that the analysis, the quality assurance. We have the use cases he's bringing up about manufacturing in the auto industry, but also across to food services. Hey, the percentage of good vegetables that are coming down the line, the percentage of bugs that we see coming down the line from whatever we farmed. These are all amazing use cases, and it's more and more we're driving that value, having the right use case, the right workloads where we need them, and eliminating that back and forth. That's an important
So,
piece.
Yeah, that's a
Awesome.
great point, Deshaun. This is Mario. I was gonna say if you want to queue up the video, I would like to show the how easy it is to instantiate and bring up an infrastructure that developers can leverage to actually take advantage of what Wallaroo does. And that's what we do. We basically bring this stuff to life. That's what Zededa does. We orchestrate, we manage full life cycle. We're fully API driven. So if you're courageous and you want to make the API calls yourself, you don't even need an infrastructure management. You can just leverage our platform to deploy what you need at the edge. So with that, I'll let you roll that. So here, what I'm showing is the edge compute that we used for the demo, and basically it's a Raspberry Pi 4 with 8 gigs of memory. I installed EvoS. So EvoS is the software that powers our edge compute, and I installed it on that SSD that I showed there. And then what I did is you basically plug it in. So if you're shipping edge compute and ship it with EvoS, it'll phone home to the orchestrator, our orchestrator, the Zededa cloud, and then it'll be attested, it'll be confirmed, it'll be onboarded, and then it becomes basically a managed endpoint. The video is kind of small there. I apologize for that. But what we're showing here is the dashboard. And then, of course, as I mentioned, we're fully API driven. In this case, I selected to use Terraform, and the first thing I did is was install EvoS, fire it up, have it phone home, and then on the cloud side, on the Zededa side, through Terraform, I create the entry for that endpoint to be onboarded, which constitutes basically an onboarding key, a serial number, and then I also push some knobs there, like my public key, just so I can SSH, make it simpler. I enable a few other knobs like enable console, enable SSH, just things that help me on a day-to-day. And then as I apply and plan, what happens is Terraform provider will create that element in the cloud, and the synchronization happens between that endpoint, the edge compute, which can be at a retail store, can be a gas station, you name it. Phone home, be attested, be confirmed and onboarded, and then basically it turns into a managed endpoint for Zededa. So here, I was showing that. I think I'm doing the apply there. And then you'll see, boom, it shows up. And see Deshaun's is already green there. But this is the new one, provisioned. What that means is I created the element, and then it goes into a booting, and then online mode basically turns green. Um, and then it gives you all of the information relevant to that endpoint, how much CPU memory is available, consumption, the network it's connected to, the disk, everything that's relevant to that endpoint. And it's fully managed from the cloud. So as you can see there, it turned green. So now it becomes a managed endpoint securely. There's a certificate exchange that happens, and then you're ready to deploy applications. So here I'm just showing interfaces that are available on that small compute, which happens to be a Raspberry Pi. So this is ARM, the ARM architecture that we deployed. And then for the sake of time here, I basically orchestrated the rest of the elements, which was number one, a network. Number two was a persistent volume, because that's where we want to save data. We want it to persist, in a reboot or a restart or respin of that container. And then I created a template which defines the edge computes the application you're deploying, how many CPU, how much memory, how much disk. It's basically how you construct that instance to be instantiated. And then the final lines of code there was actual deployment of the application. And then here I'm showing the Cloud Init. So Cloud Init is very powerful. It allows me to pre-install many packages, things that Deshaun needed. It actually allowed me to feed in the Wallaroo container information to be able to have that available as soon as that instance comes up. So all of this was automated, deployed through Terraform, and orchestrated by the Zededa cloud. And then here I show on the Wallaroo side, this is the access I was given to by Eunice, where we import some libraries, create the pipelines, push the pipelines configuration, architecture, and then it kind of spits out the Docker information that allows us to run on that edge compute. And then that container listens on port 3030 for the application to feed it data and do the inference there at the edge. Eunice, if you want to jump in and maybe elaborate a little bit more what happens there, that'd be great.
Thank you, Manny. Yeah, actually, I can go into my section and talk more about the architecture of the Wallaroo solution and basically how we enable that transfer from cloud to edge. Control room, if you don't mind, actually going to the slides within the Wallaroo section. Actually, for the audience, we'll explain and back out of what Manny was able to show in terms of how he was able to orchestrate inference endpoints that are generated by Wallaroo. So we'll wait for the
He touched on
slide
a
to
few
come
key
on.
things. He mentioned Eve. Eve is actually, it's open source. It's a part of the Linux Foundation. So the access to this type of technology is there for everybody. Then he also mentioned the phone home, right? Managing hundreds of nodes or thousands of nodes in the cloud is one thing. They're all in a region. They're all in a specific cloud. But when you talk about these edge devices, we picked on this retail use case. When you've got hundreds or thousands of stores, and where are they? Where are those devices? The way that we're deploying these is really, it's 2025, right? We're in the future. It's amazing. It's 2024 right now, but we're looking into the future, and this is the way that we're going to do things. And all of this was really well defined from the outset.
And by the way,
Exactly.
this is real. We have customers with over 20,000 nodes that are already registered in cloud and they're managing. So this is already happening today. We're already putting that infrastructure in place for guys like you, Deshaun, to take advantage.
Yep, and actually on that topic, when it comes to the Wallaroo architecture to enable these experiences where you orchestrate at the edge and also spin up an application at the edge, one thing that while designing for the future, we also have to account for the present and be able to meet our customers where they are. As I mentioned in the first slide, it's 50-50 when it comes to data running in the cloud versus data running at the edge. That's the current trend right now. So what we have designed is actually a solution that enables portable operations from the cloud to the edge. Today, if you look at AI applications in the cloud, it's all about spinning up an inference endpoint in the cloud environment that the application can actually consume. When you look at that model and you want to transport it over to the edge, you have to make sure that that transition is seamless and keeping in mind the developer on the other end who is familiar with most of the cloud constructs and how you can make that transition easy. So for us, while we focus on, of course, the deployment management of models, we also enable the capability to actually extend those deployments and inference workloads over to the edge. And in the context of a retail use case, we actually have a demo here that illustrates what that will look like if you're thinking of an AI developer that is about to actually self-serve within Wallaroo and generate that inference microservice, that inference endpoint that will run in the cloud or at the edge. There is a series of steps, not that many on our side. We simplified that with a great deal of infrastructure abstraction. So control room, if you don't mind going to the next slide, we have a demo prepared on our side to show basically what happened before Manny got to orchestrate those workloads. So that is the voice of our one and only Steve Notley, our head of field engineering, doing this demo. I don't know if the sound is coming on, but
This is Steve with the field engineering team here at Wallaroo AI, and today we're going to see how we can use the Wallaroo platform to deploy a computer vision model both to the cloud and to the edge. So what we have here is an object detection model trained to detect items on a store shelf. This could be used for something like inventory management, counting the number of items in stock at a given store, or similar applications. So to start off, I'm going to import any packages I need for my notebook, and that's going to include the import Wallaroo statement from my Wallaroo SDK as well. Next, I'll connect to my Wallaroo instance by creating a client. This will prompt me to authenticate. And at the same time, I'm going to select a workspace that I'm going to be doing this work in. The next step is going to be actually using Wallaroo to deploy this model first to the cloud. I can use this to actually test out some sample hardware for my ultimate edge deployment. And going from a saved model file to a cloud deployed service in Wallaroo is just 3 lines of code. And so let's walk through those 3 lines here. First, I'm going to upload my model to Wallaroo. This will register it with Wallaroo's internal registry and make it available for use in my pipelines later on. To do this, I give the model a name, I give Wallaroo the path to my saved model file, and I tell Wallaroo what framework it's looking at. In this case, it's an Onyx file, but this could just as easily be your favorite Python framework. Framework.tensorflow, framework.pytorch.sklearn, etc. all work exactly the same way. Next, I can configure the amount of hardware that I want to have available for this deployment. I can configure the number of CPUs, the number of GPUs, and the amount of memory that each instance of this model has. I can also specify the number of replicas or instances of this model that will be available to serve inference. This can be a static number, or it can be set to automatically scale based on demand. Of course, this is more relevant for the cloud than the edge, but as for the rest of this, a lot of people use this cloud deployment config as a way to test out how their model performs with similar resources as would be available at the edge. Finally, I can combine these ingredients to construct my pipeline that I'm going to deploy. To do this, I give my pipeline a name, I add my model to the pipeline, and then I deploy it using the deployment config I've created here. After a couple seconds, I will see that this successfully deploys, and at this point, I am fully ready and in production in the cloud. As you can see here, that means that a service has been created, it's ready to receive requests and start getting inferences. Next, we can start to test that out, and so here I will send a sample image to the pipeline, and we can see the numeric results for the boxes, classes, and confidences returned here. And just to ensure that these results are as I expect, I can go ahead and quickly plot them on top of the original image to confirm. Assuming I'm satisfied with the results here, if my target was a cloud deployment, then at this point I'm done. I have an externally available service with a RESTful endpoint that I can begin to integrate with my other applications. If my target is the edge, I can extend this deployment to the edge with just 2 additional lines of code here. The first is the publish command. This will essentially package up the Wallaroo runtime, my pipeline, and any other dependencies that I need to optimize for the hardware into a single self-contained package. The output of the publish can be used in as many edge locations as needed, but if I want to make management of those locations a little bit easier, I can also register individual edge devices and give them names through the add edge function that I have here. The output of this is the Docker container containing the Wallaroo runtime and dependencies, the specific location of this pipeline, as well as a Helm chart that covers both of these things. Additionally, if I specified a specific edge location with add edge, then I will also have the edge bundle that is unique for that location. Now, as a data scientist, these are the artifacts that I would go ahead and give to the ML engineer responsible for setting up the individual edge devices so that they can test on the hardware and ultimately roll it out.
So as we saw, this is effectively the handoff process from Wallaroo, from the data scientists working in Wallaroo, all the way over to Zededa to be able to orchestrate these inference microservices for edge application deployments.
Yeah,
Pretty powerful, isn't it?
it is, yeah. I mean, it's super powerful. Just that ease and the flexibility. I can choose, my hardware configuration, and then, it's minimum lines of code, and get that deployed. And so the other aspect, we talk about that deployment and the hurdle that companies are facing. The one other aspect that they have to consider and take into, that process is integration with existing applications and workflows and processes, and what are the best practices, like how do they do this seamlessly without creating bottlenecks and a huge upheaval. Deshaun, if I can sort of, I'll pick you out of the crowd, if you want to respond first, please.
Yeah, this idea of the team, right? We've talked about Manny deploying these edge devices. These edge devices can be deployed anywhere. Software engineer doesn't need to know. The data scientist doesn't need to know. Those devices are going to call home. But then also the models that we're deploying to those devices. The models are constantly changing. That's one of I think the biggest problems, the biggest challenges today is making sure that we have the right models deployed for the use cases. And those are constantly changing. When I just heard this idea of a pipeline, so those data scientists, the PhDs that are creating those models, they are able to now deliver it like, hey, this is the new one. This is what we need to have on the edge, because in the case of oil and gas, every drop matters, right? And again, the use cases are far and wide, and we're just starting to kind of scratch the surface. So this idea that I'm having this real mature software development kind of lifecycle, but for this AI inferencing, and now it's on the edge. it's exciting times. That's kind of the real uh, magic for me with what Wallaroo provides is I've seen a clear way of getting the right models to where the use cases need to be.
And how does VMware and Broadcom now
Yes.
handle that?
Yeah. Go ahead and play this. What I've got, as a developer, my ease of being able to leverage this is fantastic. If we can play that video, I basically went through and did the end to end. What I need to do as a developer in order to deploy to the edge, I'm going to go to start.spring.io. I'm going to create a really simple package that will allow me to leverage both the edge deployment and the models that I'm pulling from. We'll see if we can get that. And even if we don't, it's okay. It took me about 9 minutes to create from scratch an application that would go and pull an image using OpenCV for Java. I'm a Java developer using Spring Framework, and also take that image, convert that image into something that that model can understand, and then evaluate, get the information that I need. So here we're just creating an application. I'm doing it from scratch. The bottom line is it's not that much, right? What we've got from Zededa, the ability to deploy this workload anywhere. And at the end of this, I'm pushing it to a specific node. We saw in Manny's demo, there's a little video. He was using IP geolocation. So I know where these nodes are, right? When you're delivering 20,000 devices to the edge, it's hard to understand where they are. You don't have it's in this cloud, it's in this region. Those nodes have to call home. And having a way of deploying these advanced workloads to these 20,000 device nodes is important. So having that all taken care of for me, just like I'm deploying to the cloud, right? Lots of developers are comfortable with that, but now I'm getting that same type of experience and being able to just take it to wherever those workloads are, whether it's the factories or farms, or in this case, retail stores. The amount of code that I need to generate. Hey, go grab an image from whatever device is on there. This library allows me. One of the other challenges we have is what if that camera breaks? What if I need to swap it out? Having the way to deliver multiple drivers to the edge. That's my job as a software engineer, making sure that I have the right information so I can get those images from the end. That's why I chose this OpenCV library. And it's just grabbing from the first device that's connected. Manny's infrastructure said, hey, here's the USB device that we're going to connect to. So if I have to plug out or pull out a camera for one reason or another, I plug in a new one, it's still going to go and grab that first device, that first camera device. This is another challenge that's solved for us. In the cloud, you're not plugging in cameras into VMs, but in the edge, the sensors, whether it's a camera or other type of sensor, this is important. So all I'm doing here in the video is showing I'm doing it from scratch. It took 9 minutes. I sped it up, so it's only a 3-minute video, but from scratch, it's not very hard. The endpoint that was provided by Wallaroo is delivered. That's the other benefit. It was delivered not just as a container, but it could also be delivered as a Helm chart to those nodes. So I can do the same thing locally. I can validate that my code works locally, just like it's going to work on the edge. So at the end here, it's super simple. Spring Boot allows me to generate a client for the Wallaroo endpoint easily, and I can deploy it to the edge. So it works. I validated things are working locally, and at the end, I'm sending it. But knowing what I know about Zededa, I wouldn't have to connect to the 20,000 nodes. I'd hand this back to Manny, and I'd say, hey, Manny, here's my new workload. Here's how I want to have it deployed. And Manny will deliver my Java code just like he delivers the virtual machine that we're going to run on the edge. It's
That's
exciting.
great. I mean, it's a great point, and I think both from what we saw from Eunice there and yourself is, that took you 9 minutes. Eunice is, minimal amount of code. We're up and deployed, in a matter of seconds versus days, weeks, etc. And that's super important because that goes back to that obstacle that companies face in what framework do I have, do I have some of the common frameworks, or am I bringing my own custom, bring my own predict? Do I have to run pre or post processing on these models? And I think one other important thing here when we talk about the edge, you both mentioned the oil and gas as an example, but we look telecom and retail. You got have these devices that are fully remote, out there, in some extreme environments in some cases. And Manny, I'll come to you. Like, there still has to be some data while we're processing that data on the edge and making those accelerated decisions. There has to be some data that comes back to the cloud. How do we make sure that we secure that data and make sure it doesn't get hijacked on the way?
Absolutely. Decentralization does pose a lot of challenges. We know what those are. From the Zededa perspective, from our inception, because our first customers were oil and gas, we're talking about critical infrastructure here. Everything we built into our platform, and we're almost 9 years in, so we're a very mature platform, is secure end to end. So I'm talking about end to end encryption. Our communications with the cloud is encrypted end to end, encryption at rest. Our model is zero trust. EVOS is an immutable operating system with a read-only file system, cannot be changed. We leverage TPM for measured boot. We know when there's a tamper. We know when any of those PCR hashes changes, it becomes basically an untrusted endpoint. Security was built into the platform from scratch, and now every customer that comes to us can take advantage of what we built from the beginning. Guys like Eric, Saeed, right? They put a lot of thought into this, and when they created the platform, security was one of the primary uh, objectives of our platform. So end-to-end encryption, encryption at rest, everything we do is secure, and we leverage hardware TPM, like I mentioned, for that root of trust mechanism that we can leverage with those PCR values that we can take advantage of.
Yeah, great points. And so I'll bring you in as well. Manny there talked about, there is your decentralized models. How do you how do you manage those? You can't go out to every single device and manage, those pipelines and how do we do that, efficiently and effectively?
Yeah, on the Wallaroo side, actually, we have, as I mentioned, we have designed for us to meet the customers where they are currently in the cloud, and then building the ability to distribute the workloads over to the edge, or the inference endpoints really over to the edge. So that idea of starting in the cloud, having that centralized management monitoring does not go away if you distribute the inference endpoints over to the cloud. Everything still can come back centrally, with the idea that, as Manny mentioned, it was built for security. For us, it was built for performance, but also for data scientists and AI developers. So we bring you back what you actually have produced. So you produce a model, you went over to the edge. We bring the insights back where the data scientists live, so they can actually effectively assess for themselves model performance and be able to initiate, that those model updates, and be able to have that tight feedback loop regardless of where the models are being deployed. Actually, we have a demo about that to show the second part of how Wallaroo handles that once the inference endpoints are deployed at the edge. And then we can also talk from there about how we work with customers. I know we're talking about the future, the edge, but there's certainly a path there to make sure that we can accelerate our customers towards that. So maybe we can jump to the demo first, control room, if you don't mind, show what that closed loop looks like, and then we'll finish with how we work with our customers today on enabling that.
Let's go ahead and see the centralized logging that I get from these edge devices. Back in my notebook, if I examine the pipeline logs, I can see that the inference logs from my edge deployments are starting to trickle in. And if I go ahead and take a look at the metadata, in addition to the actual inference results, I can also see the name of the edge device that produced this inference, so that I can actually see where these things are run and where this data is coming from. This centralized collection of my edge inference logs allow me to not only analyze trends at specific locations or regions, but also allows me to take advantage of Wallaroo's features for automatically detecting drift. To examine how we can set up this automatic drift detection, let's take a look at the Wallaroo Operations Center UI. Here, I can see what pipelines have been created, and if I click into one, I can see various information such as version history of this pipeline. If I go over to my Insights tab, I'll be able to see what assays have already been created for this pipeline, and I'll have the option to create more. Assays are the term in Wallaroo for the automated drift detection tests that the platform provides. I can create an assay to automatically monitor any input or output variable of my pipeline for drift. So for this example, I will monitor one of my output variables, and then I can go ahead and actually select my baseline that I want to measure drift from. People here are often using training data and uploading that in order to set a baseline for their drift detection. Next, I have a lot of advanced settings that I can control, including how often my automated drift detection runs and what metrics it uses to quantify drift. I can also specify the threshold at which I want to receive an alert that drift has occurred, essentially a measurement of how different the two distributions have to be for me to consider it problematic drift. Here I can see any assays that I've created for my pipelines, and we can see that I have one on the input of this pipeline, as well as one on the average confidence, which is an output. By default, these assays will show aggregated data across all of my edge devices, but I can also segment by specific devices or groups of devices if I want. Now I can take a look at a historical period for one of my assays. And what I've done is simulate drift by feeding one of my edge devices blurred images in order to simulate a mechanical failure in one of my cameras causing faulty input data. As more of these blurred images trickle in over time, I can see the measurement of drift slowly start to increase until it crosses my threshold and begins throwing alerts. I can also click into any one of these data points to see a little bit more detail about how the distributions are different. And as I click into the data points where more drift has occurred, I can see just how different the distributions have become. Looking at the same period for the assay I have on my outputs, I can see a similar pattern, though this occurs a little slower. This makes sense since I'm simulating a defect that degrades the quality of my input images. I'll notice that effect first in the inputs and only a little bit later on in the outputs. This underscores how, in a world where I'm managing many edge deployments, I have to think a lot about what drift looks like and account for things like mechanical failures in addition to actual changes in my input or output space.
So as we saw in the video, it's really about that closed loop. You may have automated decisions at the edge, but everything comes back centrally. You can still, as a data scientist, AI developer, see how things are going and be able to actually make the decisions on when to retrain the model, when to redeploy it. So there's an automated decision at the edge around the outcome, but also a decision happening centrally about the model to come back and to retrain it and when to redeploy it.
And we went through this exercise. It's not just about the models and their drift. As we were doing this, we saw the image of my Raspberry Pi device that's sitting here connected to Zededa, the platform. A day or two ago, my device went offline. I got a message from Manny saying, hey, what happened? The notification, there's a difference. Data scientists will understand. There's a difference between a 0 value and a null value, right? My system was not connecting. When you've got 20,000 of these nodes, that every drop matters, every store matters, every piece of merchandise matters. You've got to make sure that you're getting the information, not just that, hey, you've got the right models deployed and the right software deployed, but are you connected? And when you're not connected, when the image is blurry, you have action to take. And knowing where did that blurry image come from? Having all of this connected, it really has, it's shortened the distance from what we need to do in the cloud to what we need to do on the edge. These two platforms combined are super powerful for what we're doing going forward.
Yeah, and
Yeah,
our goal,
sorry,
sorry,
go
Martin, our goal is to make it seamless for the business to focus on what they need to focus on. Infrastructure just becomes part of the process, and you don't have to focus on it. I'm sure you're not interested in it, Deshaun. You just want to be able to do what you do, and that's what we put in place.
Yeah, the other thing is we can change, right? Right now we've got the retail store use case, but a lot of these things with edge deployments, you have seasons, right? Things change, whether we're watching the roads or we're watching for weather or fires or whatever. We can change the model based on the season, whatever we need to do. And we've got pipelines that we talked about. We've got a way to deliver these new virtual machines to run on the edge, right? As a software developer, my life is easy. I can do really amazing things when I have tools like this, when I have a developer experience like this. It's a great time to be a software developer.
Yeah. Or a data scientist, right? You have,
Or data scientists for that matter.
Yeah, you have that self-service capability. I think through this conversation, what we've seen is the ability for the data scientists to, be self-sufficient and deploy those models, manage them, observe them in that, inference environment, and make sure that, they are running optimally And if they do drift, as we saw from Eunice's video, having the capability to validate a new model and deploy that in line into production without sort of taking that whole environment down is critical, especially across, you're talking about 20,000 nodes. That is super critical. And that lends itself to, our final pillar topic where, we talk about this, rapid movement and the speed at which we're going. And, the data scientists, we don't want our teams, unnecessarily have to go for training and jump through hoops and become, get in unfamiliar environments. And we are seeing, we've seen it with LLMs and Gen AI, and we're seeing it with, the change in innovation for, the edge devices. How do we, you know, what do you see emerging in the next, 6 to 12 months, as the folks on the call here, whatever stage they're at, what's going to happen, or what, if you can put your, future goggles on, how do you sort of see this evolving for edge applications?
Yeah, I
Uh,
think I can take that first one specifically because we get this question all the time, and we meet customers. They're not always advanced in their journey, which is fine. I think we not everyone is on the same path, but it's key to note a couple things. It takes a village to really ship a robust and reliable AI application. And the village here is not just one product or one software company, it's an ecosystem. That's why on the Wallaroo side, we invested in building great partnerships, Zededa, Broadcom, VMware, and others for sure, to ensure that we can deliver complete solutions to our end customers. And then as part of working with our customers, regardless of where they are in the journey, it's really starting with an iterative mindset where you the first thing is understanding the key results they want to get to, starting to prototype towards those, and then understanding from there how repeatable, how scalable those solutions can be, need to be for the business goal. Again, going back to the 90% initiatives failing to produce ROI. Here, with that mindset, you want to make sure that you're not just spinning up a prototype, you're spinning up basically a pilot for an end solution that is going to be scalable and reliable. So from there, it's really all about industrializing the solutions that we put in and working closely with our customers to go basically from either one model to many, one from cloud to edge, from basically one location to many. It's really understanding where the value is and working backwards from it in increments with rapid experimentation, rapid iterations, and learnings to be able to basically realize that ROI. So yeah, I think as a closing remark, at least on my side, when it comes to this topic in particular, it's really that close collaboration with the ecosystem and customers, and a little bit of patience also to make sure that we're able to go from the idea to the end result in a reliable way.
Awesome. Thanks, Eunice. Manny, Deshaun, do you have any sort of last comments on the future of Edge AI in the next gen?
I'll let Manny.
For me, just final thoughts is Zededa is mature. We're here. We're ready. The future looks very bright, from retail to smart cities, healthcare, automobiles, drones, industrial robots, you name it. We're seeing every use case come up from customers. So to us, it's a bright future, and I'm looking forward to it.
As a developer, one of the things that I've seen is the handoff from the data science PhDs to the software engineers that need to deploy it wherever it goes. One of the things that has really been highlighted for me is the ease of which we can start to hand off these new models and do this rapid iteration. That is a big value add. So as a developer, I've got a nice abstraction layer, just like Spring would do over the LLMs with Spring AI. What we're seeing with Wallaroo is this nice abstraction layer. So as a software developer, I've got an easy way to iterate and work together as a team with those data scientists. So So it is an exciting time.
Yeah, I mean, I think you're hitting on that sort of key word that we've heard throughout the session here is that ease, efficiency, that flexibility of to, not only integrate with existing systems and finite infrastructure, but also rapidly adopt new emerging, technologies and innovations in ways in which you can move the company forward in that strategic direction that they want to take. Before we move into the Q&A session, let's just do one more poll quickly from the audience. So, hopefully we can, get some sort of other insights here from the audience. And essentially, we've talked about deployments, we've talked about scaling, and how do we see, adopting Edge AI across, in the next, short, long term. And so, yeah, great to see in the next 6 months. As Eunice, if we go back to that Gartner hype cycle that he showed at the beginning, we see that computer vision has taken off leaps and bounds, but it's very much tied in a lot of use cases to Edge AI. We want to make sure that we can leap that chasm and not slide into that trough of disillusionment, and make that leap and bring those two elements of computer vision, Edge AI, and efficiency and reliability together into those deployments, so that you go through, if you're looking at it from 6 months, great, that is your timeline, and it's not scope creep into 18, 12 months, and then people become, disillusioned and think, this is not the return that we want. It's just too much investment. And that's where what we've seen, throughout, the conversations from that initial part of how do we scale, how do we get these devices out there, how do we get these models into production, how do we integrate with existing systems, how do we manage them centrally as well. And if there's any questions, I think, if you're looking at it in the next 6 months, what questions are burning in your mind, right now, that that you want to answer and get over. We've got our experts here. Let's take advantage of them. So I think let's have a look here. I think one of the things I'll ask a question. So I've sort of come across this is when we talked about oil and gas. How do we handle poor or intermittent connections? These devices are not continuously connected. Uh, how do we manage those ones that are out in the field, or we have poor or intermittent connection, both from a manageability standpoint, making sure that our models are performing the way they're intended to?
One of the things that we talked about like immediately was that asynchronous. Hey, are you getting the inferencing? Are you getting the analysis done where the workload is at? And one of my first questions coming into this was like, hey, am I doing the actual analysis at the edge? And the answer is yes. I can do this analysis on this small edge ready devices, but also the analysis, those logs, that's going to be sent asynchronously. So I can still do my analysis. I can still, send it to that centralized reporting system for analytics and drift, et cetera. So we're addressing it really, really well with this pattern.
Yeah, Martin, and from the beginning, as I said, so our first target customers was oil and gas, right? Critical infrastructure. Those environments are very commonly disconnected. Some of them even require air-gapped environments where they don't have any internet connection. So they need to be able to operate out of band from any external connection. So our platform was designed to do that from day one. We just now provide that to many other use cases outside of oil and gas, like retail, manufacturing, and we've expanded into those areas as we build our platform, and it has become more robust.
Eunice?
Thank you, Martin. In addition to what Manny and Deshaun said, yeah, one thing on our side where there is importance in supporting offline observability is what we call it, is the ability to as you run inferences that you're able to collect the logs on them so you can forward them when connectivity becomes available, or you can actually analyze them locally as needed. That's actually in addition to oil and gas where we saw this use case. It's also the case where today, if you're launching AI on satellites, that's something that's going to come up as well, where it's as edge as it gets, as far as it gets. So that's one of the reasons we have invested in this capability, where we support offline login, offline observability to make sure that there is the ability to run some preliminary analytics when the inference runs, but also more importantly forward them centrally to the AI developers to understand how the models are performing in those remote locations.
Excellent, thanks. We have a question from the audience. So the question is, what makes this teaming? So through Zededa, VMware, Broadcom, and Wallaroo, what makes this teaming an advantage from others in the marketplace? There are many different other companies that are spread across that life cycle from initiation right to production.
I can jump in first. So from my perspective, from our DNA is edge. With the advent of cloud, and the center of gravity kind of moving up to the cloud, everything kind of became an edge. Like, we are the original edge company, right? We operate outside the data center, ruggedized environments, no IT, bad connectivity, operating thousands and thousands of fleets. Always keep in mind when you're looking at an edge orchestration and management system does it just simply manage the endpoint, or does it allow you to treat the endpoint as a fleet? That's very, very important. Can you apply policies across the board? Can you do upgrades across the board? Can you deploy applications across the board? Can I instantiate a new Wallaroo container on 1,000 instances, right? Those are the things that you have to keep in mind and be conscious of when you're looking at an edge management and orchestration platform.
Yeah, I can jump in on what Manny mentioned, which is exactly the same point for Wallaroo when it comes to the AI layer, where we have actually built the company and the product on the promise of operationalizing AI at scale. I think that's really where the difference is. Just like Manny mentioned, edge orchestration at scale, where complexity increases. When it comes to AI deployments, it's really at scale where there's complexity. That's really where you start to see, we're going to see the ROI. It's not from deploying a pilot or something experimental. It's for building something repeatable, industrial grade that basically solves business problems. That is really the promise on which we have been built. And the partnership with Zededa and of course with VMware and Broadcom is one of the basically the tickets for us to realize that to realizing that promise.
Yeah, VMware, Broadcom, how we fit in. Hey, I'm a Spring Developer advocate. And what we've heard here is that it's language agnostic, it's framework agnostic. There's tons of ways that we can be delivering these types of workloads, but where we fit is kind of at the enterprise, at scale. You're going to find a lot of Spring developers that are out and dealing with these issues going forward. But one of the things is no enterprise, no startup is all in on one model of how they're going to deploy. Nobody is all in on the edge or all in on the data center or all in on the cloud. And that's kind of where we fit in. We kind of connect those dots. So this is just, yeah, it's a very unique, and I think that's a great question, but it works. The way that these contracts, those abstractions with the data scientist, the software engineer, the infrastructure, delivering everything as code, the way that this came together is excellent. And I wouldn't have thought of that from the outset, but now after going through this exercise and after having these great questions, I see it. And there is a really good benefit, a really good, possibility for collaboration going forward with these three companies. It's a good blend.
Yeah, I think what we're seeing here is three legs of the stool, right? You have that stability in all aspects of that life cycle. And so, great question, really appreciate it. I'd like to, we have an event coming up in a couple of weeks. So Eunice will be presenting at a webinar. You can scan the QR code there. I highly encourage you, if you'd like to, please, join us on that one, where we'll go into more insights on scaling AI inference with Wallaroo. Just finally, I'd like to thank the audience. Thank you very much for being here. I know that there's a lot of things competing for your time. Do appreciate it, and we look forward to next time. And please, look, us up. Reach out to us on LinkedIn. Look at the content that we have. We'd love to talk to you. And finally, thank you very much to our panelists here, to Manny, Deshaun, Eunice. Really appreciate your time and investment in this. And look forward to seeing you in future sessions. Thank you, folks. Have a good holiday season, and we'll see you on the other side. Bye-bye.
Thanks.
Right. Thank you.